The question was, when we increase the block size, we have already discussed that the miss rate decreases up to a point and then starts increasing again.
Yes.
Does it have any effect on hit time and miss penalty, either positive or negative? And if so, what?
Ma'am, miss penalty increases as
Okay.
block size increases.
Why?
So, search. I mean, like we go through more.
More
Increase in miss penalty is the right answer. Why does it increase in miss penalty? We have to answer that.
we increase in block size will
Increase number of pages.
number of
Basically, you need to bring in more data whenever there is a miss, right? So,
yes, so
the
search
more
time.
number of, not search time, there is no search, but there is more data you're moving from main memory to cache before you can actually handle the miss, isn't it? See, what's happening, you want a word, let us say. The word is not found in the cache. So what do? You have to bring the block which contains that word from main memory into cache, right?
Yes.
So if it's a small block, then you will bring in those many words. So if you have a 16-byte block, you have to bring 4 words into the cache from the main memory. You have a 32-byte block, you have to bring 8 words into the cache. So it's the double the number of words you have to bring into the cache, right? So obviously it's the double the time that it takes for you to move from main memory to the cache at the minimum.
Yes.
That's the miss penalty, isn't it? Miss penalty is the amount of time it takes for you to move data from main memory to the cache. Because after you move the data into the cache, only then can you handle the miss. So therefore miss penalty increases. So miss rate reduces, but miss penalty increases. And therefore, at some point, the average memory access time may increase. Okay. So we should be more focused, as I said in the last class, we should not worry only about miss rate. Looking at only the miss rate as performance of cache will actually make us do wrong things, because we should be interested in average memory access time. That should be reduced, which is a combination of hit time and miss rate and miss penalty. So if you increase block size beyond a point, the miss penalty may dominate the average memory access time, making it worse than reducing miss rate. So there are 2 problems with increasing block size beyond a point. One is the miss rate itself can go up. More importantly, the miss penalty will go up, and because of which the average memory access time can become worse. So, you can only increase the block size up to a point. That's the first optimization. Increasing cache size. Right? You increase the cache size, it helps, obviously. But what happens? What can be the negative consequences, if any, of increasing cache size?
Hit time increases.
Okay. What about overall system thing that, where look at cost, power, everything? What happens to the cost and power when you increase the cache size?
Cost increases because
Cost
cache.
increases because remember that as you go up the memory hierarchy, the cost goes up, the speed goes up, but therefore you basically have reduced size. Okay, so increasing cache will mean that your cost has to go up because you have to use more SRAM, and that will increase the cost actually. Power consumption, it depends on your associativity. If you have higher associativity, you need more circuitry, more parallel matching, and also power consumption increases with that, right? Which actually answers the next question. Increasing set associativity reduces miss rate. By the way, Tarak, you said for increased block size, conflict misses will increase. I don't think the conflict misses will increase, will they? Because, okay, you're saying there are fewer blocks in the cache, so more conflict misses. Okay, fine. So, set associativity, obviously, yeah. So, set associativity increases hit time, right? Because you have to do multiple tag matches in parallel, so it increases its time while reducing miss rate. And we also discussed a little while ago that 8-way associativity is almost as good as fully associative, so it doesn't make sense to go beyond that, right? So most of the caches use about 4-way associative. They don't go beyond that. It gets a good miss rate without increasing the hit time significantly. Okay, so that's about that optimization. So the next is there are two solutions to reducing miss penalty. One is multi-level caches, which Bhaskaran Raman's video talks well, right? At least I thought he explains it well. So here, your average memory access time is equal to hit time of level 1 cache plus miss rate of level 1 cache into miss penalty of level 1 cache, right? Now, what is miss penalty of L1? It is hit time of L2 plus miss rate of L2 into miss penalty of L2. Okay, so if you have 2-level cache, this is how you will have to calculate your average memory access time. Okay, now what sort of properties would be good for having in L1 and L2 caches? That is the question here. Any ideas on that? Probably Vasunraman covered it, but anyway, I thought we'll do some discussion. There is a lot of discussion on multi-level caches, so the rest of we don't have a lot of time. I have another 5 minutes, so I just want to talk about what properties do you think L1 and L2 caches should have. What would you like to reduce in L1 cache? What would you like to reduce in L2 cache? Of these three terms, hit time, miss rate, and miss penalty, what makes sense to reduce at the level 1 cache? And what makes sense to reduce at the level 2 cache? Hit time should be less in L1 cache, that's right. Because you are dealing directly with the processor when you're talking about L1 cache. So, you would like your hit time to be 1 clock cycle. And that means that your cache, L1 cache, should be supremely fast. What else would you like to see in the L1 cache?
Ma'am, lesser miss penalty. Less miss penalty.
Why less miss penalty? Because anyway, a miss penalty cannot be too high because you're going to L2 cash.
Mhm.
So when you say you want to reduce miss penalty, you have to look at what are the techniques that are there to reduce miss penalty, right? So is it worthwhile focusing on miss penalty at the level 1, or is it more important to focus at it, on it at level 2? So generally the focus will be that hit time should be reduced in L1 cache. Miss rate should be less in L1 cache because the higher hit ratio that you have in L1 cache, you will be having the hit time of L1 cache for all of them, right? So what you want is that when you are talking about L1 cache, you want it to be as fast as the processor most of the time. This is possible only if your miss rate is, very, very low. So we need the hit time to be very fast, and we need the miss rate to be very low in the L1 cache. When we come to L2 cache, it does not so much matter, that hit time anyway is not going to be as fast as the processor. So, forget about it. But but because it uses SRAM of a certain type, its hit time is not as bad as main memory. So you're not going to be very much worse off. Miss rate, it would be nice if you have it less, but most importantly, the miss penalty should be reduced. So how do you reduce miss penalty? In this case, actually, um, what you do is, miss rate should be reduced in L2 cache, right? Because if you have miss rate high in L2 cache, you have to go to the main memory. Okay, so then your average memory access time increases significantly. So your hit rate should be less in the second level cache. I think you're right actually. Miss penalty should be less in the first level cache, and miss rate should be less in the second level cache. The reason miss rate should be less in the second level cache is if you miss in level 2, you have to go to main memory, which is going to be a very long time. So how do you reduce miss rate? By increasing block size, right? When you increase block size, miss penalty increases, but you bring in large chunk of memory, right? So if you are bringing many small blocks because of which you are having a very high miss rate in L2, then your overall average memory access time will become high. So therefore, you would like to have low miss rate in L2, and that's why a higher block size in L2, right? So L1 cache has to be fast to reduce hit time and less miss penalty, whereas L2 should have low miss rate. So L2 caches should be also big, right? If they are not big, if they are only slightly bigger than L1, then we'll have issues with that. Okay. So anyway, there is a lot of discussion about the L2 cache, L1, multi-level caches that I want to talk about. I know Bhaskar Raman talked about local miss rate and global miss rate in his video, but we will talk about them a little more, and then other issues regarding multi-level caches and other optimizations on Friday.